Do you find math or science difficult or challenging, or you want to upgrade your metric? Krazifizix is your answer. The home of quality and inspired teaching of math and science. We offer the best service in teaching and simplifying concepts with fun and easy to remember dynamics. No one does it better. Many have had their dreams set in motion under our tutelage. We want to be part of your success story. We offer both actual and virtual tuition and homeschooling from grade 10 to 12. Are you working but need to upgrade your metric? Trust me, we got you covered, holding your hands till you make it for your metric upgrade wherever you are in South Africa. Our cloud and remote resources are adequately prepared to take you through every concept in detail. Simplified explanations, simulations to make you enjoy science and have fun with it. Textbook, workbooks, plug and play on the go class would also assist you as part of our resources. Why don't you just subscribe to our YouTube channel? Don't forget to hit the like button. Krazifizix or Crazy Edu TV. Register now for 2021. Send us an email at info@krazifizix.org.za. You'd never go wrong with us.
Good afternoon, everybody. We prepare for a live online class as we look at some concepts in paper 2. Many learners always believe that paper 2 is difficult, but hopefully with this session we would be able to raise your confidence in paper 2. So the only thing missing in this paper now is just statistics. All right, but otherwise every other thing is actually in. We would be looking at May-June 2021 paper, starting from question 3, running down till the end. So we'll look at our analytical, we'll look at the trig section, and look at the Euclidean geometry as well. So we hope that it will be beneficial to you as we run through. All right, without wasting time, let's quickly begin. Now, some of you might have gone through this paper, some of you not at all, but it is important to know that when it comes to analytical, I don't want to lie to you. Let me give you important concepts that you need. It's like a checklist. So for every topic, I'm going to try to give you a checklist. All right. So for analytical, what is my checklist? Number 1, can I find gradient? Can I find gradient? And do I understand the dynamics of gradient? Do I understand the dynamics of gradient? So I'm going to put in bracket the dynamics of gradient to say, number 1, can I find M? The properties, can I deal with parallel lines? Can I deal with perpendicular lines? Can I deal with collinear points? And can I deal with angle of inclination? Let's just say theta. Now, all of those are things that you must know when it comes to gradient. All right, very, very important. Number 2, can I calculate the equation of a line? Okay, let's say equation. So this is your checklist. Equation. Number 1, of a line, and number 2, of a circle. And when I talk about a circle, you need to understand that you need to be able to complete the square. Number 3, can I find the midpoint? Number 4, can I find area of basic shapes? Number 5, can I deal with point of intersection? And number 6, can I walk around reflection? These are the cardinal things that you must be able to do. If you can do this, trust me, you are then able to answer most of your questions. And you would see as we would run through these questions together, you've got to learn to work very fast with me today. I'm not going to do all the questions. There are questions I'm just going to quickly wait for you to get because we need to practice. All right. So here we have this question. This is basically grade 11 question. And we are looking at how many marks here? We are looking at 19 beautiful marks. All right. So we're going to work together. You are going to work as fast as you can. And if you are lost, please just quickly raise an alarm, send a message in your chat box, or you unmute yourself and talk to me. All right. We will be able to carry everyone along. In the diagram, S, please, this is how we read. You go and find S quickly. They said S, 0 and negative 16. That's my S. Quickly find it. L and Q. Wait, L. Unknown coordinate. Q. Oh, yes, there's something there. 4 and negative 8. Oh, by the way, there is a right angle triangle. This is you observing the question first. All right, Sophie wants a screenshot of that, and I'm sure you have it now. So this is your checklist for this topic, analytical geometry. I'm sure I can move on now, Sophie. Yes. You rather take screenshots?
Okay, sir.
Okay. All right, I'm sure everyone's taking screenshots now. Beautiful. All right, so we were talking about Q there, and the thing we said about Q is there is a 90-degree angle indication. That is going to play a role as we go on. All right, so we have S, L, and Q are the vertices of triangle SLQ. Quickly, we observe in the question. Having LQ perpendicular, we spoke about that, to SQ. Good. SL and SQ are produced to point R and M. SL and SQ are produced to R and M. You are quickly having an idea of what this question is all about, so that when you start dealing with it, it becomes easy to work around. All right. We are told that RM is parallel to LQ. RM, all right, we have the symbols there. SM produced cuts the X at N. Where is N? Let's find it. Oh, it cuts the X-axis at N. Lovely. QM is equal to MN. All right, I have those symbols there. There's something. I've quickly seen something. What can you tell me about M? Let's quickly discuss. What can you tell me about M? Because we are told that QM is equal to MN. There is something about M. Thank you, Mtutuzi. Mtutuzi says M is the midpoint. Lovely. I'm already thinking about the midpoint formula now. X1 plus X2 over 2. All right? Y1 plus Y2 over 2. That's what's in my head. I don't know if I'm going to need it. We'll find out just now. T and P are y-intercept. All right, lovely. Oh, I see my T and P. I hope you found it. Remember, find every point before you even start calculating. Okay. Lovely. Oh, the first question says, calculate the coordinates of M. Guys, you have 2 minutes to get me the coordinate of M. So you'll do it and then we'll mark. 3.1. Find the coordinates of M. Quickly. If you need a formula page, I'm sure you've got one. Find the coordinates of M. Very important. I need you to get these marks yourself. It's 2 marks. Let's start picking the marks now. Once I have my 3, I'm waiting for 3 answers. Once I have 3 answers, I'm going to move on. You need to be part of the 3 answers. The coordinates of M. You can zoom in on your phone to make it clearer. Or let me do this to make it bigger. So I'm going to do this. We'll just be running around the question, all right? Because I need us to have a clear image. All right, so right now we are looking for the coordinate of M. So I'll always come back to this page. Good. Coordinate of M. Oh, I have my 4 answers. Lovely. I love the way you guys are working. Ah, beautiful. This is how you work things out. Good. So let's go work out the coordinate of M. M is the midpoint of Q and N. So I'm going to then start working things out here. Let's do this as well, so that if you're watching this on a video, it can then be bold enough. Okay. It's going to be lots of slides tonight, but it will be worth your while. Beautiful. So we're looking for the coordinate of M. Okay, so all right, coordinates of M. Just getting myself a page to work with. All right, so 3.1. M is the midpoint. I'm sure we know the midpoint formula. I'm quickly going to do something here to make life very easy for me so that I don't keep going front and back. My Q is 4 and negative 8, and my N is 8 and 0. I remember that. So M is x1 plus x2 over 2, y1 plus y2 over 2. We are not going to take anything for granted. We are all going to work out every possible question. Okay, so I have x1, I have x2, y1, and y2. All I need to do, guys, is to substitute. What is my x1? 4 plus 8 over 2. What is my y? Minus 8 plus 0 over 2. And that will give me 6 and negative 4. So the coordinates of M are 6 and negative 4. Thank you for your answers. Correct. So make sure you're part of the questions and be part of providing answers. All right. No, we jump in now. The gradient of NS. The gradient of NS. Remember, we're working as fast as possible. I will give you time to take screenshots. Okay. The gradient of NS. All right. I have 4 answers already. I can then work through. So these are concepts where you pick your marks. 8, 0, 0, negative 16. Okay, so I'm just going to work through that. 3.2. The gradient of NS. gradient of ns. Okay, my n, I remember I said 8 and 0, and s is 0 and negative 16. Okay, so my gradient of ns, we know the formula, y2 minus y1 over x2 minus x1. You can actually write it as yn minus ys over xn minus xs. It also works. All right, so my y2, negative 16 minus 0 over 0 minus 8. Minus 16 over minus 8, that gives me a 2. Beautiful. Thank you. Thank you for your answers. I love it when you give me answers. 3.3. Show that the equation of the line LQ is y equals to negative half minus 6. Write down that equation. That's what we want to get. Or even if we don't write it down, guys, let's just go find the equation of LQ. That's my diagram. Find the equation of LQ. For those of you that just joined, we got our gradient here as 2. Yes? Find the equation of LQ. Once you get the equation of LQ, just type your answer in. All right, I'm waiting for one more answer. All right, lovely. So let's work through now. I think I have all the answers I need. We're looking for the equation of LQ. But one thing I know is this 90 degrees then plays a role. So if the equation, the gradient of this line here, Sn, is 2, because this line is perpendicular, the gradient of this, I'm just going to change the sign from plus to minus, and it is 2 over 1. I'm going to change it to 1 over 2. And I know that we know the principle. What is the principle that we're using there? The principle is this. All right, 3.3. The principle that we're working with is simply perpendicular lines. All right, so if two lines are perpendicular, the product of their gradient is the product of their gradient of their gradients is negative 1. So we know that m1 times m2 will be negative 1. All right, so we have the gradient of Sn as 2, And because Sn we know is perpendicular to LQ, the gradient of LQ will therefore be negative, remember, and then we reciprocate the line, the numbers. Now, do we know a point? Let's go back. Do we know a point Q? I think we do. 4 and negative 8. And that's all I need. That's all I need. There are two ways. You could either find C, because I know my Q as 4 and negative 8, which is X and Y. We can bring all of these values in. Y is negative 8, X is negative half, C is 4, X is 4 plus C. So if you do the maths, this would give you negative 2 plus C, which means C is negative 6. Some people like this method. Therefore, our Y is negative half X minus 6. Or, some people prefer this method. Y minus Y1 equals to MX minus X1. Keep your Y. What is my Y1? Negative 8. What is my gradient? Half. X minus, what is my X value? 4. Alright, so Y plus 8 equals to half. No, my gradient is negative half, right? Negative half X plus 2. Alright, so Y is, we move the 8 over. And what do we have? Negative half X minus 6. I hope that is okay. Yes, I'm here. Sophie, can you hear me? Guys, can you still hear me? Sophie's calling. Oh, all right. Okay, thank you. All right, lovely. Sophie, you wanted something? Now we go to grade 12 stuff. Determine the equation of a circle having center at O, the origin, all right? And also passing through S. Please take note of the question. We want the equation of a circle at center O and passing through what? Point S. Passing through point S. The equation of a circle at center O passing through point S. You go ahead quickly. Let's see what you are going to get. I'm just going to help you by drawing a circle passing through point S, but the center is O. All right, just to help us create an image. All right, the center is O. Find the equation of that circle. Sophie, are you okay now? Is your screen okay? Yes.
What are we calculating now?
Welshman, were you listening to the question?
No, my screen is off, so I can't see.
Guys, is your screen still on? Somebody please confirm for me. We're looking for the equation of the circle. Can you, okay, the screen is still good. Lovely. Okay, thank you. So we're looking for the equation of the circle. If you cannot see the screen, log out and log in again.
Now I can see,
right, I'm already having answers. Beautiful. Equation of the circle. Don't forget what your radius is. The center is O. I already have answers. That's my radius. Waiting for one more person to give me an answer. All right. Sophie just did that. So how do we get the equation of a circle? Equation of a circle, 3.4. This is a free mark. It is x minus a squared plus y minus b squared equals to r squared, where a and b are the coordinates of the center. Now, we were told that the center is the origin. And if it's the origin, it means 0 and 0. So what do I have? X minus 0 squared plus y minus 0 squared. And our radius is 16. Why is our radius 16? Let's go check again. Starting from the origin, passing through point S. Your radius, guys, is always positive. The reason you have a negative there is because it's below the x-axis. And I think we can quickly simplify this as x squared plus y squared equals to 16 squared. And some of you gave me this answer, 16 squared as 256. Beautiful. Well done, guys. We can move on. All right, if you want to take a screenshot, you can quickly take a screenshot of this. I'm moving on. I need us to run through as fast as we can. Hello? What the radius of the circle must start from the center to the circumference. And S is on the circumference. Can you see where S is? Yeah, so that's your radius. And I did mention that. I even used a red line to show that. And my Y value here is negative 16. So my radius is 16. 3.5, guys. The coordinate of T. I'm going to take you back to the diagram. We are looking for the coordinate of T. Interesting. We're looking for the coordinate of T. You need to analyze a few things here. The coordinate of T. Very interesting concept here. Amanda is done. Yes, Mtujuzi, we're looking for the coordinates. T is the y-intercept of Rm. We are then looking for the coordinates. Interesting. There's a principle. All right, I see. So let's work it out. Okay, let's see. You guys are giving me 0 and -1. Let me just see if we're going to have the same answer. What I see here is that LQ is parallel. All right? LQ is parallel to RM. And if those lines are parallel, it means they have the same gradient. So M is also equal to -½ Now, the coordinate, we already have the coordinate of M, by the way. That was our first question. 6 and -4. What is the coordinate of T? 0 and Y. Oh, so if I use those two coordinates, I can then find the value of my Y. Awesome. So let's work it out together. I hope it makes sense. We know the value of M and we know the value of T. So 0Y, 6, -4. All right. Let me make that white. So can I first say, this is our question 3.5, I remember. Can I first say that the gradient of RM is equal to the gradient of LQ, parallel lines? Okay, so I do have the coordinate of M as 6 and -4, and I have the coordinate of T as 0 and Y. So can I say M is Y2 minus Y1 over X2 minus X1? My gradient is -½ okay? And what is now my Y2? Let's work it out together. Y minus -4 over 0 minus 6. So -½ is Y plus 4 over -6. I think we can then work this out whichever way you want to do this. Okay. All right. What are we going to then have? Guys, are you sure it's going to give us that -1 that you guys have? Interesting. Let's see. All right, let's cross multiply. -6 there would times 1 would give me what? A 6. And I have a 2y plus 8. Okay, so we have 2y equals to 6 minus 8, which is -2. And y is -1. Beautiful. So the coordinate of T is 0 and -1. Well done. Thank you, guys. Thank you. Beautiful. 3.6. Determine LS over RS. Determine LS over RS. I'm taking you back to the diagram. LS over RS. We want LS over RS. Okay, thank you, Sophie. She's assuring me that it's 0 and -1. Yes, there's the speed of light. We need to finish this paper. And these are just normal general concepts that everyone should be able to work through fast and fast and fast. LS over RS. Interesting. If you don't know what to do, please just type I don't know. I want to see something here quickly. Because a lot of us are quiet, just waiting for others to give us answers. I want to see people who don't know what's going on. And there is nothing to be shy about it. Okay. Instead of just keeping quiet, yes, I'm getting I don't knows. Okay. Or you can just type IDK to make it easy. There's a lot of IDKs now. Completely lost. Oh my God. All right. So I've gotten a lot of IDKs. Let me just quickly walk through and save the day. Lost. I'm lost. Are you telling me we would have lost these 3 marks? Thank you, Maria. Maria just said something. I don't know, but I think we should use prop theorem. You are absolutely correct. Proportionality theorem. Oh, now you know. Mark says we should. Okay, guys, I've given you the idea, so work with it now. All those that said I don't know, now we have what to do. Use your prop theorem. Because there are 2 parallel lines. So you work it out now. I'm sure you. So it's a merge of Euclidean now. So let's quickly do Euclidean geometry. And we have parallel lines there. Do you see? Because we are looking for LS over RS. All right. So you work it out now. We know that we can then use prop theorem. I'll give you just 3 minutes. I have 2 over 3, 2 over 2. Farid, you just said it's equal to 2. Are you sure? Spelele, 2 over 2. 2 over 2 should give you 1. Oh, by the way, I forgot. Part of the checklist should actually contain distance formula. Be able to calculate the distance or the length of an object. And that is what we are going to use here. Maria, we said we are going to use proportionality theorem. Four over 1. There's so many answers coming in now. Okay, let me walk through. I have 4 over 9. Wow, so many answers. There's 2 over 3. There's 2 over 3. There's 4 over 9. There's 4 over 1. Oh, too many answers. All right. I'm just going to crop this page and walk around this page. Okay. Going to walk around this page quickly. We are looking for the we're looking for, all right, so we are searching for LS over SR. But one thing we said is using prop theorem, we can say LS over SR. Let's go check LS over SR. I'm going to highlight LS over SR. Oh, I see that it is the bottom over the total length. All right, I hope you're getting what I'm saying. The bottom LS over the total length, that should also be equal to the bottom here over the total length. SQ, so that is proportionality. SQ over the total length in that triangle, MS. And we write proportionality theorem then we say LQ is parallel to RM, which means all we need to do is to find the length of SQ. So let's find using distance formula. I'm sure you still remember. LSQ will be the square root of x1 minus x2 squared plus y1 minus y2 squared. Just the distance formula. All right, so if you look at S and Q, all right, so you have 0 minus 4, the x values, plus the y values, minus 16 minus negative 8 all squared. And all you need to do is to throw that in your calculator. So if you throw this in a calculator, what are you going to get? 0 minus 4, 4 squared would give us what, 16? All right, plus 8 minus 16 would give us what, 8 times 2, 64. Okay, and this would give us the square root of t. Okay, done. Now let's look for SM. Again, using the distance formula, we're just going to throw in our values now. x2 minus x1. All right, let's use the x value. SM, 6 and 0. 6 minus 0 squared plus the y values, negative 4 and negative 16. Don't forget the squared. 6 squared will give me 36. And then we have 16 minus 4, that is 12. 12 squared will give me 144. Just use your calculator, guys. And then we have, our answer should be the square root of 144 plus 36. All right, I hope you're working along with me. So LS over SR will be equal to the square root of 80 over the square root of 180. I hope I'm going to get your answers now. Let's check quickly with a calculator. Square root of 80 over square root of 180. 2 over 3. And that is your answer. Please let me know if we are okay. Those of you that gave me wrong answers, different answers, are we okay? We're moving over question 2. Can I get okays or lost? You have 1 minute to give me your responses. You cannot leave your answer as 4 over 9. 4 over 9. No, 4 over 9 is not the same as 2 over 3. Four over 9 is wrong. You cannot have 4 over 9. 4 over 9 is different from 2 over 3. So, Messiah, you need to find where you made a mistake. All right, you see it. Beautiful. All right, thank you, guys. We're moving on to the next question. So, that was just a very lovely question, and many of us were not so observant on what to do. I think we have one more question. Calculate the area of PTMQ. I'm just going to do this one for you quickly. Calculate the area of PTMQ. I'm going to quickly do this one to save time. PTMQ. Let me crop this page so that we're done with this on time. PTMQ. And I'll show you a skill here, just so in an exam you don't remember. Many of us don't remember how to calculate these areas. So the first thing is to go look for PTMQ. All right, I see that my PTMQ is a trapezium. PTMQ is a trapezium. I know if I ask you now to find the area of a trapezium, you would not remember. Okay, so I'm just going to show you in an exam, how would you remember this formula should you have such a problem? So first, we have identified that it is a trapezium. Now, a trapezium is made up of two things, a rectangle and a triangle. By the way, that should be a perpendicular height, so that's h. All right. I hope we are together. That needs to make sense to you. All right. Now, I will call this A and call this whole length B. I'm trying to show you how to quickly get the formula, just in case you forget in an exam. Quite a lot of people don't remember. All right. Now, but if I call that whole length B, don't forget that this is A as well, opposite sides of a rectangle. It means this small side on the right is B minus A. I hope that makes sense. All right. So if I have my triangle, it's actually length times breadth, right? And the area here is half base times height. You could calculate the area of the two and add. All right. You could calculate the area of two, but that is going to be a bit of a problem here, because then I need to find, okay, no, but wait, I think, do we have point P? We can get point P, all right? We're actually going to need point P. Yes, we would need point P, all right? And then we already have our, let me see quickly. We already have this as 0 and -1. All right, so let's quickly generate that formula so that we can then see. I hope you're okay. Now, the rectangle area is length times breadth, which is what? A times h, plus the triangle half base times height. Half, what is my base? B minus A times the height. You can do this in an exam to make your life easy. Don't cram it. Simplify. AH plus half BH minus half A multiplied by H. Oh, like terms. AH minus half AH. I'm doing this because many of us don't remember these areas. This is 1, guys. 1 minus half would give me half AH plus half BH. Oh, what's common? Half H A plus B. That is the area of a trapezium. Should you forget in an exam, use the skill that I did. Quickly divide it into 2. Calculate the area of the rectangle, calculate the area of the triangle, and add them together. But this is how we get the formula of a trapezium. All right. What is A and what is B? They are the parallel lines of my trapezium, which means the area here can then be half. Don't forget, your height should be perpendicular, and my perpendicular side here is MQ, and the 2 parallel sides are PQ plus TM. All right, you'd need to digest this with time and make sure you are able to interpret what I did. Okay, so area is half the height. Please never forget that height is always perpendicular to the base. So you would see they gave us that perpendicular sign there. All right, base and height are perpendicular, and then we have the sum of the 2 opposite sides. But by the way, I think we are going to have a small challenge. The challenge is we do not know the coordinate of P. But I'm sure we can get it since we got the coordinate of T. Everybody, let's quickly work out the coordinate of P. Everybody, let's quickly work out the coordinate of P, the same way we did that of T. We know the gradient as -half. We know our Q. Quickly work out Y for me, because once we get the Y, we can then work out the distance. Lovely. I'm seeing answers coming through. I just need us to confirm that answer. I am seeing a 0 and -6. All right. Okay, 0 and -6. Let me quickly work it out with us. Let me work it out with us now so that we move on. And in case you are lost, you can quickly catch us now. The gradient of QP, we got it as -half. So it means -half equals to, remember, y2 minus y1 over x2 minus x1. Let me do this so that I have a single symbol through. Okay, so -half, my y2 is -8 minus, I do not know the y value, over 4 minus 0. Let's work it out together. If we cross multiply there, that will give us -4, all right, equals to, I could do this. Let me try something here with you. I don't know if you see what I'm doing. I left my 2. -4 divided by 2 would give me -2 equals to -8 minus y. We move this there. What do we have? 6. All right, you guys are correct. Beautiful. Y equals to -6. Awesome. Now, quickly, saving time, let's now calculate our distance. We calculate the distances. I'm going to ask you to give me the distances so that we can work through. Just trying to draw the shape again. All right. Trying to draw the shape again. All right. There we go. And we are told that is 90 degrees. So this is P, this is T, this is M, and this is Q. 4 and -8. I remember our M is 6 and -4, 0 and -1, 0 and -6. We said area is half height A plus B, and we interpreted as half. What is the height again? Remember, the height must be perpendicular. So that's my height, MQ. And the sum of the parallel sides, PQ plus TM. Quickly, guys, I want you to start working out the different lengths. Whatever length you work out, please let me know. Somebody is working out MQ, somebody work out PQ, and somebody is working out TM. Tell me your answers so that we can then just write the answers. Oh yes, Zama, we also have the equation. That could have actually been easier. Thank you, Zama. We also have the equation. That would have been easier. Quickly, everybody now. Work out those lengths, MQ, PQ. Make sure you are doing one of them so that you are confident that you can work out these things. I'm waiting for answers. MQ, PQ, TM. Don't just give me the length, give me the letters as well. To say MQ is 5. Somebody else PQ, somebody else TM. So we should be done in 30 seconds. All the three should come in. Distance formula. All right, I have my first MQ as 2 root 5 or root 20. Just confirm in case it's different. MQ is square root of 20, which is the same thing as 2 root 5. Who's giving me PQ? Please confirm. I'm not going to work it out now. I've done the distance formula for you. TM is 3 root 5. Somebody's giving me 3 root 5. All right, just to confirm here, somebody is giving me 2 root 5 there. And what is PQ? Is PQ also 2 root 5? Which one are you giving me? MQ, please guys, let us confirm. TM 3 root 5, MQ 2 root 5. PQ is also 2 root 5. Oh, okay. PQ and MQ equal. All right, I'll take your answers for it because it seems that we all have the same answer. What's my MQ? 2 root 5. Then we substitute 2 root 5 plus 3 root 5. All right, you then give me your final answer. All right, thank you guys. I've taken all your answers and I trust you. Is our final answer 25? In case your answer is different from this, you need to work it out later when we are done. Half times 2 would be, so I'm just going to say root 5, and we open a bracket. All right, I'm getting the final answer now. 2 root 5, that would be 5 root 5. 25. Getting 25, and since it's area, units squared. All right, I hope we are all good. So in case you lost somewhere, please check those length formulas again. Check those distance formulas again, please. We need to move to the next question. I hope this part of the session has been okay. We should be getting 19 marks. Beautiful. I enjoyed myself. Thank you for the prompt answers that you've given me, and I hope no one is lost. All right, we have our next question. We have our next question here. Just going to crop this for visibility purposes. All right, let's quickly go through the statements together. In the diagram, P, remember what I said. Don't just read. It's not a newspaper. This is not Romeo and Juliet. Don't just read, brr, no. In the diagram, P, negative 3 and 4, go and find it. I've seen it. Is the center of the circle. Oh yes, it makes sense. It is the center of a circle. V, K, and negative 1, okay, and W are the endpoints of a diameter. Ah, that's a diameter. I'm quickly thinking about something that is a radius, and that's a radius. We'll see if it's going to help along the way. The circle intersects the y-axis at B and C. Find B and C. Familiarize yourself with those points. BCVW is a cyclic. These guys are bringing in Euclidean. So in case you don't like Euclidean, I'm sorry. There are questions you would not be able to deal with. So that is a cyclic quadrilateral. Okay. CV is produced to the x-axis at T. All right, I see there. And we are given the angle as alpha. Definitely. I know I'm going to use my angle of inclination. Tan alpha will be equal to m somewhere along the line. All right, let's go look at the questions. So we familiarized ourselves with this whole statement. Okay, now here we go. Let's start looking at the questions now. Just going to crop this and make it bigger for us to see. Okay, there we go. Beautiful, big enough. 4.1. The radius of the circle is square root 10. Calculate the value of k. So we're looking for k. If k, a value of k, if point V is to the right of point Q, clearly, 5 marks. Show all calculations. We are looking for the value of k. The radius is root 10. I'll go back and write root 10. Do you want to try square root of 10? I'll give you 3 minutes. And when I say 3 minutes, let's make it 3.5 minutes. It's 5 marks. Let's just make it 4. Quickly. Time counting down. 4 minutes. I want you to try. Try first before we see what to do. It's so easy. In fact, 4 minutes is just too much. But you work it out. Sophie, the question is find the value of k. We know the radius PV as root 10. Find the value of k. Musa Elvis, you are stuck, but I need you to give me a trial. You need to put something down. Elvis. There must be something that you can do. 5 marks, and we need to at least get a few marks. You would notice that PV is the distance between 2 points. So basically, we're using our distance formula. Elvis, I'm sure you remember your distance formula. Good, you're welcome. So I'll be waiting for your answer. You have a few minutes left. Time is ticking. All right, I have so many answers telling me that K is -2. Guys, we're going to stretch tonight. All right, if we finish in 4 hours, it's okay with me. All right, so, because we need to get all of this done. All right, let me quickly walk you through now. 37 seconds left, but I'm going to just cut the time. I know that I'm working with the distance formula. PV is square root of 10. Remember, if you go back to the things I said you should know, this is one of the things. You must be able to manipulate your distance formula. Thank you, Lesedi. Thank you, Lerato, Mduduzi. Mduduzi, you cannot give me -4. We are told that V is on the right side. Okay. All right, so we're going to use our distance formula quickly. PV, this is 4.1, equals to square root of 10. Okay, so can I then say PV is X? I'm going to put my squared here. X1 minus X2 is just easier. Squared plus Y1 minus Y2 squared. By the way, do I have my coordinates? I like to write these coordinates out. It makes life a bit easy for me. I know the center of the circle P as -3 and 4, and I have my V as K and 1. So we are going to then substitute everything that we have. All right, square root of 10, that's PV, but it's all squared. X1, we can use K minus -3 all squared plus 1 minus 4 squared. I hope we are all on the same page. And this would give me 10 equals to K plus 3 squared plus 3, -3 squared, right? Please, it is important. I'm just going to make a note here. We find a lot of learners making mistake here. Guys, we FOIL here. We don't distribute. We FOIL. And if I FOIL, what am I going to have? 10 would be equal to what? K squared plus 6K plus 9 plus 9. I'm sure you know what I did. We need to then have a quadratic equation. 0 K squared plus 6K. This is 18. And if I move the 10 over, it becomes a negative. So 18 minus 10 would give me 8. Oh, easy stuff now. I see that I am going to have K plus 2, my factors. I'm sure, guys, look, this we cannot negotiate. Factorization, we cannot negotiate that. If you need to spend an hour on that, please do. K equals to -2 or K equals to -4. I want us to quickly talk about something here. I've got 2 answers and I want us to interpret these 2 answers. I'm going to go back to the diagram. Why do we have 2 answers? Why do we have 2 answers? Check this. The radius here is also root 10. Ah, makes sense. And if the radius here is also root 10, it means K here could either be -2 or -4 here. I hope that makes sense because that's my k. That would work out to root 10. That's why we have two answers. I see. The examiner said it's on the right side of P. If it's on the right side, it has to be -2. Makes sense now. But that -4 should be kept. We might just need it along the way. I hope that makes sense. So my V is -2. So we're going to only accept K as -2. Awesome. Beautiful. Thank you for those lovely answers. And in case you were lost, Elvis, I hope you are fine now. Hi. What do you need, Welshman? All right. Yes? Check that it says that V is to the right side of P. So if you have -2 and -4, K is -2. Just going to use a different color. You should be able to see your answer now. It's on the right side of P. Which one is on the right? Is it -2 or -4? Dan, that's your answer. Yes, you substitute and manipulate your distance formula. So you have the two coordinates and the distance between them. Beautiful. You okay now? You're welcome. Look at the next question. The equation of the given circle is x squared plus 6y. Please write that equation down. X squared plus 6x plus y squared minus 8y plus 15 equals to 0. I'm going to repeat that just in case you missed it. X squared plus 6x plus y squared minus 8y plus 15 equals to 0. All right. Now, calculate the length of BC. Take you back to the circle. Let me write the equation here for you. It's x squared plus 6x minus y squared. So plus y squared minus 8y plus 15 equals to 0. Find the length of BC. Interesting. Study the diagram carefully. There is something about B and C. It's the y-intercept. Beautiful. I like what you're seeing. I like where you're going. B and C are the y-intercept. There is something about y-intercept. There is something we learned in grade 9 about y-intercept. There is something very important we learned about y-intercept. X equals to 0. So, and B and C are on the circle. So what do we then do? So you find me the length of B and C. It's 4 marks. Good. So guys, since they are on the circle, substitute x equals to 0. And let's find the value of y. You would also get 2 answers for y. Let's get that done quickly. Oh, there are 2 done, 2 units. Oh, all right. I see you guys are moving so fast. Oh, okay. I have a few answers in, so let's work it out together now. Thank you, Jablani. Thank you, Marcia. Thank you, Welsh. Thank you, Sophie. All right. Please, there are a number of people who are not participating. I'd suggest that you participate, work it out. All right. It's important. Okay, so let's go find B and C. 4.2 now. And then we'll run to our trigs quickly. So x squared plus 6y plus y squared minus 8y plus 15 equals to 0. But I know that at my y-intercept, x equals to 0. So 0 squared, no, this is not y here. It's an x. All right, plus 6 multiplied by 0 plus y squared minus 8y plus 15 equals to 0. Now we can quickly solve that. Do you see again, guys? Factorization is key. Y minus 3 and y minus 5 equals to 0. Y equals to 3 or y equals to 5. Let's check something here. Which one is my B and which one is my C? B is actually higher, so B should be 5 and C should be 3. Oh, so I see where you guys got your answers from. Smart. The distance between B and C is just 2 units. Beautiful. So BC, I hope you got the 2. BC is 2 units. Lovely. But if I were you in an exam, I'd write out the coordinates. B is 0 and 5. C is 0 and 3. Therefore, BC is 2 units. Lovely. Let's run to the next question. All right. Oh, sorry, Ayush. You can take a screenshot. We're done with 4.1 and 4.2. So you can take a screenshot. Once the board is full, we can take a screenshot. I'm so sorry. I just got excited about maths and kept moving, you know. Some of you are excited with food. I'm excited with maths. All right? Are we okay now? Yes. You can use the distance formula, but there's no need. You are looking for just the length of BC. Go back to your diagram. That's why I wrote it there. C is 3, B is 5. What is the distance between the two? Absolutely, and you're done. Next question. If K is negative 2, calculate, okay, I'm going to need you to mute your mics. There's a lot of noise. All right. If k is negative 2, oh, which was what we got? Calculate, okay guys, we have two questions to do, but let's start with the first one. Calculate the value of alpha. K is negative 2. Now we know our k as negative 2. Please get the value of alpha. Interesting. I love this. Get the value of alpha. Interesting. Amanda is done. 45. Waiting for answers. In Tabelane, you have 63,43. That answer, I'm not comfortable with it. All right, so this is an angle, right? So we can simply work with tan alpha is equal to m, where m is the gradient. All right, now these again are collinear points. We do have the coordinate of C, all right, 0 and 3. And we have the coordinate of V, -2 and 1. All right, so if we have those coordinates, it means we can actually find our gradient, right? So let's quickly find the gradient of VC. Let's find the gradient of VC. We do have those points. I need a fresh page now. The gradient of VC. Just get something white. MVC, remember, would be y2 minus y1. By the way, what's our C? Our C is 0 and 3, and our V is -2 and 1. Makes it easier. All right. So y2 minus y1, 3 minus 1 over 0 minus -2. The gradient of VC, therefore, 2 over 2, which is 1. Easy now. Tan alpha equals to m. Tan alpha equals to 1. We know what to do. Shift 10, and we get 45 degrees. Beautiful. This is question 4.3. In case you are lost, I hope I've been able to find you. Thank you for giving me correct answers. Maths is in trouble. The way you guys are giving me answers, mathematics is in trouble. All right. Let's look at the next question. 4.4. Find the size or calculate the size of VWB. Take you back to the diagram. VWB. VW. Okay, let me just highlight it for you. VWB. Looking for that angle there. Yes. VWB. This requires a bit of Euclidean, I see. Adolf, do you want to please mute your mic? Adolf, please mute your microphone. All right, use your Euclidean here, guys. Use your Euclidean. This is very interesting. I love what I'm saying. We're going to use opposite angles of the cyclic chord 180. Maybe, I think so. You can try. Tamima, please try. But I want you to get an answer. I love it when we try. Find the size of VWB.
So say, are we finding the size of W?
VWB. So we're looking for that angle.
We are looking for which angle? W or B?
V. How do you interpret VWB? You need to learn to interpret that. VWB. I have actually put a blue dot. Good. VWB. If you are lost, just quickly type lost. I need to see what I'm dealing with. I see so many lost people. Guys, please don't be lost. Don't be lost. Don't be lost. Look at this. Can I quickly analyze that? If I have this as 45, let's check this. This angle here is 45. That is a Cartesian plane which is 90. It means that this angle here is also 45. Looking at this triangle. Please try to follow through. Looking at that triangle there. Sum of angles in a triangle, so that is 45. Now you have your cyclic chord. Oh, exterior angle is equal to opposite interior, and we're done. 45. Thank you. I see answers are now coming in. I hope that makes sense. Angle W is equal to the exterior of angle C. Alright, so if I have that as 45, it's also equal to 45. But it is important to state how you got the 45. Thank you. Now, I see you guys are now getting there. So let's quickly write down our answers. How did we get to 45? 45. Let's state it. 4.4. Angle OCT is 45 degrees. Sum of angles in a triangle. Sum of angles, all right, in a triangle. We can therefore say that VWB is equal to OCT, and that is equal to 45 degrees. Exterior angle is equal to opposite interior angle. I hope we are okay with that. And just in case you didn't see that exterior, look, you've got something like this. Let me just make this line a bit thinner. Just in case that exterior is a problem, you didn't see it. Look, you could walk around something like that. You've got this, you've got that, and you've got this. Okay, although my triangle is a bit skewed, let's just elongate that. All right, so you've got this, remember? And that's my axis there. So this is 45, 90 here, okay? And if that's 90, this is also 45. Mind you, this is a straight line. So you could have actually said this is 135, just in case you do not see all of that. Now that's 135, and we know the properties of a cyclic chord, that these and these are what? Complementary. Therefore, W is 180 minus 135, and that will give you 45 degrees. I hope it makes sense, and I'm sure we're okay. All right, so in case you don't see, use opposite sides of a cyclic chord are supplementary. All right, I'm sure that makes a lot of sense. Let's move quickly. What is our next question? 4.4. Okay, you know what? To save time, I'm going to run through 4.4 with you, because I know these reflection things are just so I'm going to run through 4.4 with you. A new circle is obtained when the given circle is reflected about the line y is equal to 1. What does that mean? A new circle. Let's get a new page. Let's quickly get a new page. I want to show you some. Okay, you can screenshot this. I'm done with this page. You can screenshot that. I want to quickly help you with that reflection thing. All right. I'm going to the next page now. Time. To make this easy, you know what I'm going to do? Let me try to construct the question for us here. Okay, that's my axis there. I do have, now I'm going to need to do something different. Let me put this here because I want to reflect it. Okay, so I'm going to have my circle. My circle is somewhere hanging there. All right, but it does cut that. All right, so we have that B and C up there. Okay, and we have our point V there, which is -2 and 1. -2 and 1. All right, so I want to do something here for you. Put a line there. Okay, beautiful. I'm reconstructing the circle so that we can walk through together. We're given that. Okay, are we here? Am I losing network? Okay, just a... All right. Okay, I think we okay now. Just... Okay, let's just hold on for the network to be stable. All right. Okay, I think now. Guys, I'm just trying to reconstruct the circle quickly. All right, I'm trying to reconstruct the circle quickly to make things easier for us. And for reconstruction's sake, let me take my one up a little bit so that we see what the examiner meant when this thing is reflected along one. Okay, it's fine. Good. I'm just quickly reconstructing that, and I have that there. Okay, so this is -2 and 1. So that is 1. All right. Now, we are reflecting this circle along, this is -3 and 4, point P. We're reflecting this along y equals to 1. Reflect along y equals to 1. What is the new circle going to look like? So I am taking this circle and flipping it over. Watch what I'm going to do. I am going to redraw a new circle here of the same radius, because we're just reflecting that, right? So let me just see if I can get exact size. Good. I tried to get that exact circle. Lovely. Now, I am going to take the green one, and it's going to be the image of the white one. So let me flip it. Flip. And I'm going to flip. Okay, it's not doing what I want it to do. Okay, let me try again. Okay, I'm just going to move it manually. It's not doing what I expected it to do. So I am flipping the white to have the green. The green is going to be the new circle, but I am flipping along x equals to 1. Basically, what I'm doing is I am turning it upside down such that my x equals to 1 is the mirror. That's where the mirror is. When I turn this upside down, it's going to look like that. Okay, it's not going to be a perfect image. I don't know if you can picture that. I have turned it upside down. So you're flipping it. I wish I could turn my camera on and flip what I'm trying to show you. All right. So you take the circle and flip it upside down along y equals to 1. Hold on. Such that, because I am flipping it from top to bottom, watch this. If you get my next statement, we are all good. The x still remains the same because I am flipping it upside down. That is my x value, -3. The center of this circle is just turning upside down. My x still remains -3. But what happens to my y? That is the question. Now, if I flip it, this is how we do it. If I flip it around y, what is the distance? Remember, this is the mirror now. Now, when I flip it over, the distance here will be mirrored as the distance here. It's going to be the same distance, equal distance. The difference between 4 and 1 is 3 units. It means I am going to move 3 units here as well. So if this is 1, this is going to be negative what? 2. Because from 4 to 1 is 3 units. Go down 3 units again because the mirror is here. 3 units up, 3 units down. So turn it down from 1. What is 1 minus 3? Remember, down is minus. Minus 3 units, I have negative 2. If you understand this, then you are good with what the examiner is trying to do. Reflecting along a particular line. Talk to me, people. I am turning this over around y equals to 1. It doesn't change my x because it's just a vertical turnaround. Amanda, you're lost. Good. I'll re-explain. Please listen here. I have a circle here. All right? Let's take this circle and turn it. So this is point A on the circle. All right? Turn it around here. This is point B. So if I take this circle and bring this over here, turn it, just flip it over, it means that your A would come here. It's now upside down. Does that make sense? I turn it over. Okay, those of you that are lost, I need you to listen again. I take my A, this is the mirror, guys. So take A and turn it over. Something is turning over that line. So my A was at the top. Now my A would be at the bottom. I hope that makes sense. So whatever I have at the top comes to the bottom because I am flipping over y equals to 1. I'm glad some of you are understanding. Those of you that are lost, I'm finding you quickly. So from the top to the bottom, we flip it over. You just turn it around. All right? It's like you're taking something vertically up and then flipping it over to go down. Okay? I don't know if that makes sense to you. Does that make sense to you now? Just the flip. Talk to me if the flipping over makes sense. You take it from the top and turn it upside down. The top becomes the bottom becomes the top. Because I am flipping along a horizontal line where the mirror is. Good. I'm finding you. Lovely. Yes, Spelele. Okay, hold on. I'm going to find you now. Just give me a second. All right. So first we understand that it turns upside down. Is that okay? Good. Now, the distance here, this is my 1. This is 4. What is the difference between 4 and 1? 3 units. When you turn this thing upside down, I am going to have 3 units as well away from here because that is my mirror. The mirror is here. So if it's 3 units above, it must be 3 units below. Now, if this y value is 1, what is the y value here? 4 minus 3 would give me 1. 1 minus 3 would give me negative 2. That's how I got my answers. Talk to me now.
Okay, so how you got the y information, but then what you got the x value?
My x is not changing. I just explained 1 minus 3, negative 2. 3 units down. That's my negative 2. Okay, 1, 1. Tabisile, talk to me.
Okay, can I just ask me? You got the 3 units there, and then you took the y value, which is 1, and you said what? 1 minus 3 or what?
Yes.
Negative 2.
Yes. Understand what the reflection is. The reflection is a mirror. Put that at the back of your mind. The reflection is a mirror. All right? So if I have a mirror here and I have 3 units away from the mirror, from the top, reflection is 3 units away at the bottom. So move down 3 units. How do you move down 3 units from 1? You have 0, you have -1, you have -2. First unit, second unit, third unit. Are we okay?
Yes.
All right, and Paul, we okay? That's how you deal with your reflection. And for the x, guys, I am not changing my x because we are reflecting upside down. That's why I use this orange line for you. We're just taking this thing and turn it upside down. So the x still remains. In fact, what you should be interested in further is this. Look at this line. This line is still going to meet this line there. That's going somewhere. So these circles are touching at 2 points. That's very interesting. There and there. Because we take it and just throw it upside down. I hope it makes sense, people. All right. So if that is the case, my x values remains the same and my y value is now -2. 3 units up and 3 units down. Why 3? We are reflecting along y equals to 1. So I look at the 4, okay, reflecting along that. It's 4 units to the 1. That's where the mirror is. 3 units. I must look for another 3 units. All right. I hope, guys, thank you for your responses. The first question says 4.4.1. What does it say? It says coordinate of Q, the center of the new circle. I think we're done. Determine the coordinate of the center. So what is the center here? 4.4.1. Q, the center, will be what? -3 and -2. Make sense? 4.4.2. Let's check. 4.4.2 says, where is it? Good. Equation of the new circle. We want the equation of the new circle. Let's go work that out. Equation of the new circle. Guys, we have our center. Okay, A and B as the center of the circle. I don't even need to write it. It's at the top there. Okay. Oops. What is the radius of the circle? Guys, it is still the same circle. Don't forget. It is still the same what? Circle. So the radius is square root of 10. So what is going to be the equation of the circle? Remember, x minus a squared plus y minus b squared equals to r squared. What is my a? -3. So it becomes positive. -2, minus minus, right? And what is the radius? Square root of 10. And that will give me 10. And I'm done. Talk to me. Because my r is root 10. Root 10 squared would give me 10. And that's the equation of the circle. I hope that makes sense. Can I get your responses? Just type okay if you're okay. So at least today now you understand what we mean by reflection. So the reflection is a mirror. When you reflect, whatever you have on the left is the same as what you have on the right. So take note of that. Reflection. What you have on the left will be exactly what you are going to have on the right. Okay, beautiful. Thank you so much. Look at 4.4.3. This examiner is just playing. But the thing is, if you do not understand that first statement, you will be completely lost. 4.4.3. Determine the equations of the lines drawn parallel to the y-axis. Parallel to the y means they must be vertical, right? And passing through the point of intersection. Passing through the point of intersection. Tabsile, you may ask, guys, here are the point of intersection. Yes.
Is also the same on the right. Do the signs change or they remain the same?
Okay. It depends on where you are reflecting. Guys, let me quickly help Tabisile here and do something, and we'll come back to that answer. Look at this. It depends. Now you are in grade 12. It depends on where you are reflecting from. Okay? Very key. It depends on where we are reflecting from. If I reflect, for example, check this. Let's pick a point here. Let's pick a point here. -3 and +4. If I reflect along the y-axis, take note. I am reflecting along the y. It means my y becomes the mirror. What I have on the left should be the same on the right, the distance. So take this point and throw it over to the right hand side. What am I going to have? It is 3 units here, right? So I'm going to move 3 units here. What will I have? -3. But my y value remains the same. It gives me 4. I want you to get what I'm trying to do here. I'm reflecting along the y-axis now. Is that okay? Let's reflect along the x-axis. I'm going to use a different color. It means my x-axis becomes the mirror. So this thing is coming, we're reflecting this one. It's coming down. So take this point and bring it down. It's going to be here. All right, if I'm reflecting, do you see that it is still there? My x is -3. But how far am I from the mirror? 4 units. How far will I be here? 4 units, which gives me -4. This is reflecting along y and x. But if I reflect, I'm going to go to a new page now. If I reflect this, I don't want to reflect along y and x now. That's grade 10. I want to reflect along a different line. This is -3 and 4. I want us to reflect this along, watch this now. Let's reflect this along -1. That's my x, right? Good. So this is my mirror now. It means if I reflect, this thing is going to be on the right hand side. Turn it over. But how many units am I away from the mirror? If this is -1, -2, -3. How many units? 2 units, right? Which means I am going to be away here. How many units? 2 as well. Good. So if it's -3 here, what will it be here? 2 units. From here to here, 0. From here to here? Good. So I am going to be at point 1 here. But what happens to my y value? It is still on the same level, right? 1 and 4. Are you good now? Quickly, let's reflect along y equals to 2. So if I reflect along y equals to 2, it's coming down now, right? If it comes down, my x is still going to be where it is, -3. But my y, how far are we from the mirror? 2 units, because that is 2. Are you okay? So it means below the mirror, I need to be how many units away? 2. 1, 0. So I'm right here now. Are you okay? 4 minus 2 would give me 2. 2 minus 2 would give me what? 0. I have reflected along y equals to 2. Are you good now? All right. That's how we work reflection out. Okay. You're welcome. All right, quickly, let's answer the last question. The last question says that we should, I've actually forgotten the question now. It says, find the equations of the line drawn parallel to the y-axis, passing through the point of intersection. Oh, I was explaining the point of intersection. Where are my points of intersection? There. Now we got a value here as -4. So what is the equation of that straight line? We're looking for this equation, guys. If you see it, we're looking for that. All right, although it's not perfectly drawn straight. And I'm looking for that. They said parallel to the y-axis. What is my y value there? My x value there? -2. And here, -4. So 4.4.3, x equals to -2, and x equals to -4. The examiner said equations. Read. Let's read. Equations of the lines. There are 2 of them. Equations of the lines. Guys, are we okay with... it's been a long question, but I love what we've done. Talk to me. Talk to me. We need to move quickly. Did it make sense? Okay, Benny is still lost. The last question, I'm going to quickly try to repeat for you, Benny. Please. Welshman, we say please. So if I have a circle here, now I did explain that we have reflected, that we are okay. All right. So we've reflected. Just going to... All right. This is my mirror. This is what I wanted to do earlier on. All right. So we have that there. Because we reflected along this line. All right. We reflected along this line. The point of intersections are there. Okay. my my x-axis there, and my y there. And we know this, if you remember, guys, we had this point. And I told you that point is going to play a role later. -4, and we have -2. So because this thing is reflected, the x-axis still remains the same. All right, so we have that. So what's the value here? -4. They said equations that are parallel to the y-axis. Equations, these are equations of vertical lines. Equations that are parallel to the y-axis. So you're talking about vertical lines of intersection. My circle intersect here. What is the value? -2. My circle intersect here. What is the value? -4. So what's the equation of this line? X equals to -2, x equals to -4. Point of intersection. So those are the points of intersection. We reflect the circle. So we take the circle and turn it over at y equals to 1. Just imagine it. That you take, I wish I could have a 3D to make you see what I'm saying. We take this circle, this is the top, all right? We hold it there and turn it over. Now the top is now here. So the top comes there, but it is turning at this point. It turns over at that point. So this is my new circle, and that's the old one. But we have, okay, good guys. It's like saying you have a rope here to tie these two circles together. If you turn this one, it's going to become the bottom one. My point of intersections are still going to be there, -2 and -4. All right, thank you. You get it now. Beautiful. So the main idea is understanding the reflection principle. That you reflect about a point, that point becomes a mirror. All right. Quickly, we're done with our analytical. I really enjoyed that session. Beautiful. Trigs. This 18 marks, very fast. Can I walk around the 18 marks? Just follow through, because I want to save time. Simplify the expressions. Okay, let me do this. I'm going to do this. 3, 4, and 5. All right. So I'm working around my first one. Simplify the expression. Guys, for trig, please understand that sine -x is equal to negative sine x. It's not algebra. For those that have been in my class know that it's not algebra. It's a trig ratio, negative angles. Tan -x is also equal to negative tan x. Please do not forget these important points about trigs. Time is not on my side now. I would have loved to give you your checklist for trigs as well, but that is one of your checklists. So, quickly, tan -x can be written as what? Let me do this. Let's take it down one by one. This is negative tan x, which is also negative sine x over cos x. Not double negative. Don't say negative sine over negative cos. No. That's my first point. All right, cos x in between there. There's nothing I can do about that. That remains cos x. Now, what about sine x minus 180? I am quickly going to accommodate 3 different ways of doing this. Pick what works for you. All right, the first method is to try to do a sign change. Oh, by the way, hold on. Before I do that sign change, don't forget what we have. Okay, theta, 180 minus theta, 180 plus theta, 360 minus theta. All students take Coke, you know. All right. Now, first method is to do a sign change here. Bring out a negative. Okay. Now, this looks like the first one here. And that gives us the negative sine x becomes negative sine 180 minus x, right? And 180 minus x is in the second quadrant, and sine is positive. But I'm still going to have this negative out. So negative, positive sine x, method number one. I don't know if you are comfortable with that. If you are not comfortable, use your compound angles. Sine x minus 180, compound angles. This will be sine x cos 180. All right. Please make sure you use your formula page. Is that all right? In case, so that you don't make a mistake. Don't make a mistake. All right. With the sine, our sine remains the same, right? Minus sine 180 cos x. Use a calculator here. Cos 180 is minus 1. Minus 1 times sine x would give you negative sine x. Sine 180 is 0. So the whole of this gives you 0. I have negative sine x. That's my second method. Find what works for you. Number 3 is to say, since this is a negative angle, I am going to rotate it one cycle by adding 360 to it. It's a negative angle. Rotate it by adding 360. One full revolution. What will this give you? Sine. What is 360 minus 180? It is 180 plus x. I hope that makes sense. I am in the third quadrant, and sine is negative. Negative sine x. I have shown you 3 different ways of working that out. Choose whichever one works for you. But I want to tell you, I prefer the second one because it's a formula. All my answers will just pop out. All right. Now that I have my 3 solutions, let's see. The examiner says we should reduce this into a single trig ratio. Do you want to take a screenshot? I want to go to a different page now quickly. Going to a new page. Taking a screenshot already? All right. So what I have now is I'm going to have negative sine x. Remember, we changed that. Please use brackets when you are multiplying. Important. Our cos x remains the same. That's what we got. All right. The sine 1x minus 180 is negative sine x, and the whole thing minus 1. Maybe I should just rewrite the question here for you. This is what we're changing. We're changing negative tan negative x. Tan negative x multiplied by cos x multiplied by sine x minus 180 minus 1. So we have reduced all of those or changed them. What are we going to have here? This will divide that. Negative times negative would give us positive. So what do we have? Sine squared x minus 1. But remember that sine squared x plus cos squared x equals to 1. Okay, if I want sine x minus 1, can I bring this there and take this there? What do I have? Sine squared x minus 1 equals to what? Negative cos squared x. So my answer here all right, so my final answer, this one is equal to what? Negative cos squared x. This is just me explaining how I got that answer. Thank you, Uncle Oops. Thank you. Guys, are we okay with this? Let's run. Let's run. Are we okay with this? Let me get your responses quickly. Thank you, Tabby. All right, all good. This is, how many marks? This should have been 1, 2, about 4 marks. All right, we're okay. Beautiful. Thank you so much. All right, let's look at the next one, 5.2. For clarity, I'm going to do that. Let's quickly get this 5 marks. For time, I'm going to do it. Cos 35. Okay, the examiner says cos 35. This is basically m over 1. Don't forget. They said without the use of a calculator, so that means I need my quadrants. Now, cos is positive here. It means I am in the first quadrant. I am in the first quadrant. And you should remember, those of you that we've been together know that we have what you call a trig bow tie. And that angle is 35. Adjacent over hypotenuse. Adjacent over hypotenuse. Ka. You remember that, right? My hypotenuse, therefore, is 1. My adjacent is m. I do not know that. Please show how you got your y. You never know. There could be marks there. 1 squared equals to y squared plus m squared. So if I move that over, y squared will be 1 minus m squared. What is y? The square root. Remember, it is plus or minus. But in this case, we are working with plus because we are in the first quadrant. Beautiful. Okay. I haven't done that. Let's get our marks now. Cos 215. Let's reduce that. Let me use a white here. Cos 215. 215 is in which quadrant? Don't forget theta. 180 minus theta. 180 plus theta. 360 minus theta. And we have cast. All right. 215 is in which quadrant? Thank you, Ayush. Is it the second? Thank you, Tabisile. It's in the third. So how do we reduce that? Cos 180 plus 35, I think. Yes. Thank you. 180 plus 35. Oh, and cos is negative. Negative cos 35. And what would that be? Negative m. Everybody good? Everybody good? 2 marks there, guys. 2 marks. We quickly get those 2 marks fast on our way to university. All right. Let's get the next one. I know the next one looks tricky. 5.2.2. Sine 20. You know what I'm checking here is how do I get 20 from here? I've got a 35. Even if I were to calculate this angle, 90 minus 35 would give me what? 55. 20 is not coming out. Okay, wait. Can I bring in my S? You said 55 minus 34. Okay, you could work that out, but that's very long. But 55 minus 34 will not even give you 20. Minus 35. Okay. So you want to go that way. Okay. Let's see. Sine 55 minus 35. Lovely. But guys, don't expand it. Don't expand. It's not algebra. So this will have given you sine 55. This is very long though. Cos 35 minus cos 55 sine 35. Let's work it out. I like the idea. What is sine? Opposite over hypotenuse, which is m. Sine, I'm using 55 now. So it is m. What is cos 35? Also m. Okay. Minus. What is cos 55? Adjacent over hypotenuse. If 55 is my angle, it means I'm working with y. Y over 1, which is 1 minus m squared over 1, okay, multiplied by sine 35. Let's check. Sine 35. Sine 35 opposite over hypotenuse, which is still y over 1. All right. Square root of 1 minus m squared. What will this give us? M squared minus, all right. The square root and the square root of that can deal with each other. What would I have? I'll have 1 minus m squared. I hope we are still together. I hope it's making sense, because I want to work with different options that we have. Okay? All right, now, so if we then deal with this, let's expand. M squared minus 1. Negative times negative would give us positive. All right, so this would give us what? 2m squared minus 1. Yes, talk to me. Listening? I'm listening. Yes, I used compound angles, sine, cos, cosine. All right. Tabisile, where are you lost? Tabs. Tabisile, we used compound angles here. Sine 35, so sine alpha minus beta is sine cos minus cosine. And I'm going back to my triangle using my SOHCAHTOA. So sine 55, let me use a highlighter. 55 becomes my angle. Sine is opposite over hypotenuse. Over hypotenuse 1. So that's how I got my m. Cos 35, adjacent. So if this is my angle, this is adjacent, m over 1. Minus, what is cos 55? Cos 55, adjacent. Y over 1 becomes my adjacent. Y. My y is that. And my sine 35. Okay, you good. So our final answer is 2m squared minus 1. But you know what? I wouldn't have done this though. Look at what I would have done. There's nothing wrong with this. Please don't get me wrong. So I'm going to create a second page. There's nothing wrong with this. It's absolutely correct. All right. There is nothing, I take nothing out of that. 5.2.2. I could have said sine 20 is the same as cos 70, co-ratios. And I see my 70 as a double angle. Cos 70 is the same as cos 2 times 35. My aim was to get 35. All right. So if you go back, what is cos 2 theta from your formula page? 2 cos squared theta minus 1. So basically, cos 2 times 35. You see my angle is 35. 2 cos squared 35 minus 1. What is my cos 35? We are given cos 35 is m, but it is m squared minus 1. And I'm done. Yes?
Can I ask this? You said sine 20 is equal to cos 70. Why did you get 70?
Do you know co-ratios?
Yes, you said 90 minus 20.
Yeah. So what is 90 minus 20? That's your 70 there. Sophie? Yes. No, I was just trying to look at other options that I got. Sophie, are you okay now? So this is what you had in mind as well. All right. So guys, you can take a screenshot of the first page, first solution. There is nothing wrong with this solution. I love it. I love it. I love the thinking there. Who gave me that again? Amanda, well done. Lovely. Amanda, good thinking. All right. Then I have the second solution using my co-ratios. We subtract it from 90 and change the co-ratios. All right. Quickly. Let's go to 5.3. Screenshotted. 5.3. Let me see. Do I still have another page here? All right. 5.3. General solution. Please understand the rule of general solution. Avoid dividing anyhow. Don't just divide. All right, quickly, going to work this out again, trying to save some time. Look at this. Oh, interesting. Cos 4x, cos x, plus sine x. Ah, I see something here. Cos, sine, sine. 4x, x, 4x. Compound angles. I hope you see it. Cos, sine, sine. That compound angle must be with you. You must know it. So you remember that cos alpha minus beta is cos alpha, cos beta, plus sine alpha, sine beta, which looks like what I have. So definitely this then becomes cos 4x minus x equals to negative 0.7. And this gives me 4x minus x, 3x equals to, all right. So guys, I am just applying my compound angle. Alpha beta plus is alpha minus beta. And it's cos, sine, sine. Okay. Haven't gotten to this point, we need to find our reference angle. And how do we find our reference angle? Look, when you're looking for reference angle, theta, forget about the negative for now. All right, forget about the negative. Theta would be shift cos of 0.7. Forget about the negative. We will deal with the negative. What is my angle here? Shift cos 0.7. 45.57. 45.57. So theta is 45.57 degrees. Now let's walk around the negative. What does the negative tell you? It tells you that we are in the second quadrant and the third. I hope that makes sense. We are in the second quadrant and the third because that is where cos is negative. This is how I do mine. Might be different from what you do at school, but I just write my reduction. Okay, so I am then going to work out and say 3x is equal to 180 minus, what is my theta? 45.57 plus K360, and K is an element of integers. I'm sure you know that rule. So what is 180 minus 45.57? What would that give me? 134.43. So 3x is 134.43 plus K360. Let's divide by 3 because we're looking for x. 134.43 divided by 3 would give me 44.81 plus K. We need to divide this by 3 too. K120. Remember, K is an element of integers. I hope that makes sense. And then we repeat the same thing on the right hand side. 180 plus. So 3x is 180 plus 45.57 plus K360, K being an element of integers. What is 3x going to be? That should give us 225, I think. 225 plus K360. No, 225.57. Please confirm and bring me back should I have made a mistake, because I just added. Yeah. So what is my x? We divide by 3. 225.57 divided by 3 would give me 75.19. Thank you, Nompumelelo. 75.19 plus K. Remember, you need to divide that too. 120, and K is an element of integers. All right, that's how you deal with your general solution. Thank you, Nompumelelo, for those lovely answers. All right, we're good. Awesome. Awesome stuff. I hope there's no question. Screenshots, please, because I need to move to the next question. Let me get your responses. Okay. Let me get your responses. I'd love that. All right. Thank you. I think we have the last question here. Proving an identity. Proving an identity. All right. 4 marks. This should be easy. Sine 4x cos 2x minus 2 cos 4x sine x cos x over tan 2x. 2x. Let's prove it from the left-hand side. Let's check something here. All right, I need to get cos and sine. Okay, I'm seeing something interesting here. 4x, 4x, 2x. Oh, 2 sine x cos x. That's an identity on its own. Cos 4x. Now I have 2 sine x cos x. Do you remember that 2 sine x cos x is the same thing as sine 2x? All right. Over. I need to change this 10 because my answer does not have a 10. So sine 2x over cos 2x. Look at the top again. Look at the numerator. It's very easy. Thank you. Okay. All right, Benny. Sorry, I just saw your message now. You figured it out. Look at the top. Sine 4x. Look, it's sine cos, cos sine. 4x, 2x. Oh, again, it's compound. I hope you see it. It's another compound. And basically, that is sine. So we are going to have sine 4x minus 2x. Okay, divided by, I like to do this for simplicity. So what do we have? Sine 2x times cos 2x over sine 2x. Oh, so our final answer is cos 2x, which is there on our formula page, actually the first one. And we're done. Which second step, Sophie? The compound angle. Is it this one? Sine 4x cos 2x minus cos 4x sine 2x. This is basically sine alpha cos beta minus, do you see that my 4x is alpha? Cos alpha sine beta. Compound angle. And this is basically sine alpha minus beta. Where is the cos 4x? Tabisile, I'm lost with your question. The cos 4x has gone in here. It is your compound angle. You see it now, right? Good. So you must observe what the question is. It's a sine, cos, cosine. Start thinking about compound angles quickly. So it's 4x minus 2x. Hello, Welsh. Where are you confused? Which one? Do you know your compound angle? Okay, so how would you expand sine 4x minus 2x? How would you expand it? Uh-huh. Yep. Mm-hmm. Yep. And this is it. So that is equal to that. All right? And 4x minus 2x is 2x. And that will cancel each other, and we are left with that. Tabi, are you fine?
Yes, thank you, sir. I get.
Okay, beautiful. So we are done with that question, guys. I think for the night, I'm just going to end with the next question trig. And probably the next session, I will then look at the Euclidean part. All right. Oh, I've got 2 more questions on trig. All right. That is lovely. All right. We've got a trig graph here. Ah, interesting. Interesting. Let's quickly run through the trig graph as well. In the diagram below, the graphs of f of x equals to cos 2x and g of x equals to negative sine x are drawn from the interval negative 180 to positive 180. A and B, find them quickly. Got them? A and B are 2 points of intersection of f and g. Beautiful. Without using a calculator, determine the values of x. So basically, again, guys, this is general solutions. Graphs are another way of asking you for general solution. I'm going to need, let me just quickly do something here. All right, so guys, we are going to end the session tonight. So part 1 will end with just this question with trigs, and then we would see how to go on. All right, so this is what I have. For clarity, now I want to prove, or sorry, not proving, I want to find x. Again, it is general solution. It is general solution. Just going to move that up so I can have a well-cut image. And I'm actually interested in this trigonometry. Learners just find it difficult. Okay, so this is what we have. Cos 2x equals to negative sine x. We want to find the general solution here. You can start if you are confident in yourself, because it's just general solution. Please avoid dividing. It's very tricky. Look at what I would do here. I would rather have it as a standard solution. Cos 2x plus sine x equals to 0. Now, try to make it of 1 trig ratio. Change your cos 2x into sine. I'm sure we remember, if it's a sine ratio, 1 minus 2 sine squared x. We remember that, right? Plus sine x equals to 0. Looks like a trinomial. Let's see. Let's rearrange. Multiply through by negative so that I have a trinomial minus sine x minus 1 equals. That's actually a trinomial. Some of you don't like this. Let's do this to make it easy. Let sine x be equal to k. What do you have? 2k squared minus k. Do you see? It's a trinomial. I'm sure you know how to solve this. This would be 2k. That would be k. I want to get negative 1, so I could have plus 1 minus 1 equals to 0. Yes. So it's either 2k plus 1 equals to 0, which means k is negative 1 over 2, or k minus 1 equals to 0, and k equals to 1. All right. Non Pumelelo. If you use cos squared x minus sine squared x, see, what you should do is try to see if you can work with a single ratio. It makes life easy for you. All right. Try to see that option first. That's why I changed that into a sine trig ratio, so that I have a single trig ratio across the board. I hope it makes sense, no Melelo. That's always your first option. Make it a single trig ratio. So I have sine x equals to negative half. Can we now find our angles? Okay.
So say, when you say 2 sine squared x minus sine x minus 1 is equals to 0 there.
Yeah.
Did you use your, for that one that you said negative 1 minus sine 1 minus 2 sine squared x? Did you use your double angle?
Cos 2x, it's there in your formula page. Do you have a formula page? Please use your formula page.
So say if you can use the other one that is saying let's say cos 2x minus sine squared x. Are you home?
It will become more difficult for you. That's what I was explaining right now. What is it? Plus sine x. Look, it becomes more complex. One of the easiest way of doing trig ratio is try to work around a single trig ratio. Try to work around a single. See, I try to change everything to sine. It makes life easy for me. Good. So it's always an easier method if you can. All right, so my sine is negative half. Negative tells me I'm in which quadrant. Let's quickly get our reference angle. Theta is what? Shift sine of half. 60, I think. Sine 60 is half. No, sine 30 is half. All right. Okay, had to quickly change mics. All right, now my reference angle is 30. I'm sure everybody knows that now. And I'm working with a negative. Okay? I'm working with a negative. So what do? Negative, I'm in the, which quadrant am I in? Third and fourth. Okay. Third and fourth. That's why it's 6 marks. There are a lot of solutions here. Third, and my third is 180 plus theta, and my fourth is 360 minus theta. So what is x? Can I just say 210? Because I've added, all right? Plus k 360, and k is an element of integers. I've simply said 180 plus 30. 360 minus 30, 330, plus k 360. K is an element of integers. But hold on, there is a problem. I am given a restriction. Check this. My restriction has to be between negative 180 and 180. Let's quickly find what our angles would be. How do I find these angles? We start changing k. That's why we say k is an element of integers. All right? So if k is 0, 0 plus 360, 0 times 360 will be 0. My first angle is 210. That is actually out. Let's check. If k is 1, 360, no, that's actually going extra. Can we change it to the opposite now? Negative integers. Let your k be negative 1. So basically this is what you're doing. K is 0, negative 1, 1, 2, because all of these are integers. So if my k is negative 1, what would I have? I would have 210 minus 360. 210, no, I'm making a mistake. Negative 150. Oh yes, it falls in my range. Beautiful. What about 2? 2 would be too far. 360 times negative 2 will be 720. No, that's way out of my answer. Nah. So I am done. I have my first answer. X equals to negative 150. Good. What about the side? 360, if it's 0, it won't work. But I see that I could have k as negative 1 as well. 330 minus 360 would give me negative 30. It works. It is between. Guys, I hope what I'm doing here makes sense. It is between that. I'm doing all of that because I am given a restriction. So I need to list my angles. I think I have my answers here. Because if I move away from all of those k's, then I'm having something different. All right. That is the first answer. The second answer, should I have lost you there, I'll find you here. Sine x equals to 1. What is my reference angle? Arc sine of 1 is 90. Oh, beautiful. All right, arc sine of 90. So sine 90, you can check. Sine 90 is 1. So x equals to 90. The rest won't work because the next angle that will be equal to 1 will be 270. These are called marginal angles. So I have 3 solutions. Here are my solutions. Negative 150, negative 30, and 90. Wait, this is going to make sense just now. I have 3 solutions of where cos 2x, hold on, oh, I'm so excited with this. Cos 2x is equal to negative sine x. This equals simply means point of intersection. So these graphs we are saying intersect 3 times. Let's go check our graphs and see. This graph intersects 3 times. I'm bringing that graph down. This graph intersects 3 times. There we go. Check your first point of intersection. 3 points now, which means we are correct with our general solution. A, B, and there. The first one was negative 150, so A should be negative 150. Then we got negative 30, and then we got 90. That is how you work out your. So in case you are lost with general solution, by now you should no longer be lost. That's how you work out your general solutions. So we have our 3 answers. Negative 150, negative 30, and 90. And we're done. So those are, you see, they said A and B are 2 points of intersection. But there's another point there of intersection. Negative 150, negative 30, and 90. and I got all of those from my general solution. You want to take a screenshot here? Because I'm done with this page. And I'll be finishing the session just now. You can then, go over the questions again. This is May, June 2021, written, I think, 2 weeks ago or so. So we're going through, we're creating a memo now, a video memo of this. All right, screenshot taken. Let's now answer more questions quickly. It says 6.2.1. How many degrees are point A and B apart? How many I want you to answer this question for me. How many degrees apart are points A and B from each other? How many degrees apart are points A and B from each other? I'm waiting for your answers. I'll keep repeating. How many degrees apart? The answer is staring right in your face. Ooh, Amanda, thank you so much. Beautiful. Thank you, Sophie. 120 degrees. Lovely. Thank you, Mtuduzi. 120. Yeah. 120 degrees. That is how far they are apart from each other. Well done, Tamira. Well done, Tokozizi. Now, guys, do you see how important your general solution is? 120 degrees. 6.2.2. I know these questions are hectic. Please, f prime of x, I'm going to show you how to interpret these questions greater than 0. Never forget that here we're talking about gradients. Now we are saying the gradient of f and the gradient of g multiplied together should be greater than 0. Start interpreting from the... All right? I do mine by interpreting from the right. I want to get something greater than 0. It means that I need to get a positive answer. I want to multiply two things to get positive. What does it mean? It means both of them should be positive or both of them should be negative. I hope that makes sense. Please follow through. I want to do this just once. The first thing is understand that f prime of x is gradient. G prime of x is also gradient. All right. So I want to get a positive if I multiply. When I multiply to get a positive, both of them must be positive or both of them negative. Okay. Let's check this. Both of them positive or both of them negative. Let's quickly walk around. I'm going to go back to my graph. All right, I have a graph. Should I use this graph? Okay, let me, all right. Let's walk around our gradient here, guys. We're walking around gradients. Look at what I'm going to do to help you see the gradients. I'm going to actually draw gradients to make you see this. Take this out. This is our gradient page. All right, f prime of x, remember, write the question. F prime of x multiplied by g prime of x greater than 0. Both have to be positive or both negative. Let's draw gradients. Look, your gradient is just a straight line. All right, so I'll use the blue one for f. The gradient of this is like this. Is this my f, by the way? No, this is g. All right, gradient here is that. Okay, gradient is this here. Continues. All right, and gradient. So this is my G. Gradient here is 0. Turning point. Okay, I'm going to write my values here. Watch this. I'm using the blue. Gradient here is positive. Up until the turning point, 0. Then this is analytical geometry, right? Remember, gradient here is negative. Gradient here is 0. I'm sure you remember analytical. Okay, that's fine. I'm going to use a red one for F. The gradient here, all right? Gradient here. The gradient here. Don't get confused. The gradient here. The gradient here. The gradient here. And the gradient here. All right, let's use a red one. I love this page. It looks nice. Negative, 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 0. Positive, 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 0. Negative, 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 negative. All across 0. Positive, positive, positive. All right. What are we looking for? We are looking for where both are negative or where both are positive. Let me take a green line. Watch this green line. Good. I'm going to be moving the green line. All right. At this point, do you see it? My green line is touching positive and negative. No. I am looking for positive, positive, negative, negative. See, it's still touching positive and negative. It gets to 0. Negative, the blue is negative, the red is positive. It goes on, the red is positive, blue is negative. It gets to 0. Wait, immediately after 0, what do you see? Both of them are negative. Awesome. That's what I'm looking for. It continues. At this point, it's 0. And after that, both of them are positive. What am I looking for? Where both of them are negative and where both of them are positive, which is here. Both of them negative and both of them positive. So that happens except at 90. Just want to show you that. Because at 90, it is 0. Do you see my boxes? They are both negative in the green box, and they are both positive in the pink box. What is my answer? In the green box, it is between, okay guys, I'm going to write this in English first. Between 0 and 90. That's the green one. And in the pink one, what is it? Between 90 and 180. How do I write my answers? Amanda, you were wrong. So the green one would be between 0 and 90, and between 90 and 180, because I'm given a restriction. All right, my restriction is between negative 180 and positive 180. Amanda, I hope it makes sense. All right. And Mduduzi and Ayush, it's less than or equal to 180. Be mindful of your restriction. Now, Amanda, if you want to write your answer that way, this is what you could have written. 0 till 180, but x cannot be equal to 90. So these are the two ways of answering. Option 1, option 2. I hope you please get the difference. All right, get the difference between the two options. Between 0 and 180, 180 is inclusive, but you must state that x should not be equal to 90. Amanda, did you get that? And if you use the first option, 0 less than x less than 90, look, any time you use the word between, use this inequality less than, less than. I hope you got that. Anytime you use that inequality, use less than, less than. Between is less than, less than. Awesome session. I'm loving this. Let's do the last question tonight. Let's do the last one. And this last one, please, guys, I want you to please listen. A lot of learners struggle with this last question, and I want us to work around it together. I hope we're okay with what I did with the trig. Tabisile, are you trying to say something?
Can I please have the screenshot for 6.2.1 and 6.2.3?
You may. Where is it again? I might have lost it somewhere. Yep. So my 6.2 is actually after this. Okay.
Sir,
Yes, Ayush.
is it possible to just go through the slides once again before ending and just to check if we have all of them?
You know what I'll do, Ayush? I'll send you a PDF on the groups.
Yes, sir.
I'll do that.
Thank you. Okay, sir.
So make sure you are on the group. If you are in this class and you are not in any of the groups, I am going to send a message right now in the chat box, okay, that will give you links to the classrooms. You don't have to join all, okay, to save your data. Just join one. I will then send the PDF of this when we are done. All right, just send. There are 5 or 6 classes, so just need to join one. All right. I think I have 3. Okay, hold on. Let's sort out this message quickly. Do you guys have the 5 or is it 3? Just a second. All right, so just join one. You don't need to join the whole thing. All right, so quickly. The last question, guys. The last question. Learners skip. This is where they join the gym, by all means. The gym here. Because they just keep. All right, it's not Virgin Active, guys. It's a MET exam. Stop gymming. I'm going to quickly crop this page to make it easy for me to explain. Okay, just a second, guys. My system is now running a bit slow. Okay. I hope the session has been very okay and informative for you, getting you ready for whenever you're going to write.
Yes, sir.
All right, check this now. Okay, I wanted this and have the question on the side. All right. for which values of k, determine the values of k for which cos 2x plus 3 will have no solution. Which one is our cos graph again? All right, remember the question, guys. Our f of x is our cos graph, so we're focusing here. Okay, guys, anytime you see such questions, this is how you approach this question. Try to manipulate the equation to have either f or g. In this case, it's quite simple. It is f. So we have cos 2x plus 3 equals to k. Cos 2x equals to k minus 3. Oh, so this is f of x equals to k minus 3. Remember, your f of x is the same thing as y. Y is equal to k minus 3. This is what I have been able to deduce from my equation. But the examiner says, determine, this is functions as well, functions. Determine the values of k such that this thing here would have no solution. When we say a graph or a function has no solution, what do we mean? Please listen carefully. We're rounding up the class tonight on this note. Watch my f of x. The time I will not have a solution will be when I have this. Watch what I'm going to do. Look at that red line, guys. Please, I'm going to explain a few things here. You see, when I'm here, I'm actually having a lot of solutions. What are my solutions? Solutions can be regarded as your x-intercept. So do you see that? Okay, my line is definitely not a straight line. I'm going to try to draw a straight line from that point to that point. Yes, clever. So I have a straight line. I have solutions. Where will I not have solutions? Look, when I'm here, I don't have solutions. Why? The line is not touching the graph. I have no solution. Again, I would have no solution here when the graph is not touching. Remember, I'm dealing with cos 2x. So keep your eye. Let me try to shade. Oops, sorry, my mic is making noise. Let me try to shade cos 2x just to be able to help our sight. So I'm looking at this. All right, so we're focusing on that color, right? Good. Do you guys know that that cos, the highest value of cos x is 1, maximum, and the minimum value is -1. And that's going to be the same thing here because I am not shifting this graph. The 2x only affects the period, not the maximum and minimum. It means my maximum value is still 1 and my minimum value is still -1. Watch this. For me, please, I need to listen to this. I'm done already. For me not to have a solution, I am working with my blue line on top and my red line below. It simply means, tell me if you are okay now, that y, because this equation, this line is an equation of y has to be greater than 1. And in this case, y has to be less than -1. I will have no solutions at those points. Talk to me before I finish. Let me quickly repeat before you start giving me your response. For me not to have a solution, the graph should not touch the horizontal line. All right? The graph should not touch the horizontal line. Can you still hear me? The graph should not touch the horizontal line. Where will the graph not touch the horizontal line? I have two of those lines, the red line and the blue line. Why am I saying horizontal? Because that's my y equals to. So anywhere above 1, the graph will not touch the line. Anywhere below -1, it will not touch. And because it's a horizontal line, y is less than -1. And the blue line, y is greater than 1. Please give me your responses now. Are you okay? Because I am done. I'm waiting for your responses, and I'm going to prove it for you. They would end the class. Great. Good. But what is my y? Y is equal to k minus 3. So we said y should be greater than 1. What is y? K minus 3 greater than 1. So k should be greater than 4. Or y is less than what? -1. Y is k minus 3. Your inequalities, right? K, if I move that over to the other side, it becomes a positive. Positive 3 minus 1. K should be less than 2. Hold on. I am going to show you that we are right. This is how we prove that we are right, and then we would end the class. Cos 2x plus 3 equals to k. Watch this. Cos 2x plus 3 equals to k. We said for k not to have, for this thing not to have a solution, k should be greater than 4 or k less than 2. K should be greater than 4 or k less than 2. Let's pick a number greater than 4, 5. So cos 2x plus 3 equals to 5. Let's go check. Cos 2x equals to 5 minus 3. Cos 2x equals to 2. 2x equals to shift cos of 2. Get your calculator and work it out. What is shift cos of 2? Error. Solution. In fact, 2 is too big a number. Let's pick 4.1. So we used 5 here. Let's pick, we picked 5. Let's pick 4.1 because 4.1 is greater than 4. Cos 2x plus 3 equals to 4.1. Cos 2x equals to 1.1. Okay, so 2x equals to cos, shift cos 1,1. Take your calculator and check. Shift cos 1,1. Error. Solution. I don't know if this makes sense to you. If I were to pick a number lesser than 4, give me an example. A number less than 4? Give me an example. 3. Lovely. So if I have cos 2x plus 3, in fact, let's choose 3,9. I want us to pick the closest. what are we going to have? Cos 2x will be 3,9 minus 3. Cos 2x would be equal to what? 0,9, I think. Yes. Get your calculator. Shift cos. Do you see that you have an answer? Which is different from the other ones. Other ones, we didn't have a solution. So guys, this is how you deal with it. You can walk around the case less than 2 as well. Give me a number less than 2. 1. Okay. So if we have cos 2x plus 3, a number less than 2, 1. Cos 2x equals to 1 minus 3. Cos 2x equals to negative 2. 2x equals to shift cos of negative 2. Pick a calculator quickly. I'm just showing you that it gives you an error. So there is no solution. This is what we mean by no solution. All right. So what are my answers? My answers are k greater than 4 or k less than 2. By the way, k is an element of real numbers. A lot of learners don't know how to tackle such questions, but I believe after now you understand what solutions mean, what roots mean. All right. You can take a screenshot of this. Oh no, but I said I'm sending you the PDF, then you can go through. All right. So guys, this is us dealing with graphs and general solution. Whew, I thought we were going to finish this in 2 hours, but we have, look at this, we have the strict question left, and we have our Euclidean geometry. All right, so we could not finish. This is part 1.